is not going to be about languages like R or Python or any other interesting languages you might think of, although I'll have statements about why that's really not as important. This talk is also not going to be about advanced machine learning tools. I'd love to talk to you about random forests and boosting and decision trees and deep learning. I'm currently building a deep learning library in R. I'd love to talk to you about that. Not talking about that today. What I will tell you is why that stuff isn't terribly important either. This talk, which I've now done about 10 times in Australia and previously in Singapore, is it's really what I think people need to know about data science. What can I squeeze into 45 minutes of data of the presentation for people who are either aspiring data scientists or particularly business leaders who are looking to create data science functions or introduce data science into their business. And along the way, I want to identify what it is and what it isn't. I'll return to those points in several different ways. I should also say that the cartoons that Kai-Shin put up earlier, which I may return to in question time, were probably a very poignant summary of my whole presentation. Those cartoons are actually brilliant. And I'll actually go through some of them, and heck, I'm going to steal them and put them on my Twitter feed later today. So, well, let's go through what I promised this talk was going to be about. So I told you it's going to be about various things, and you came along, so it kind of worked. So I promised that I'll be telling you all of this. Great. But, well, kind of, there's sort of a change of plan. Because, well, I'm not lying. I will kind of tell you that, but I'll probably tell you all of that in a way you didn't expect. So, and before I tell you anything, I'm just going to tell you about me, because I've got a business to run. That's how we operate. So yeah, there'll be some shameless self-promotion. The way I'm going to present stuff to you, which will kind of be the Dilbert view of data science, like, I think there's a huge disconnect between what data science can do for business and what I think it does for business in practice. A lot of it has to do with education, a lot of it has to do with incentives, a lot of it has to do with the kind of leadership we tend to have in business today. I'm going to try to give you a few parables and metaphors and weird, abstract, philosophical stuff. Hopefully I'll surprise you, and hopefully I'll challenge and reframe a lot of your conventional thinking. Along the way, I will also define what I mean by data science, particularly the science bit. The data bit I think you're more comfortable with. The science bit is the interesting part. And some of you may be saying, okay, yeah, that's great. How's this relevant to my life? I want to learn about deep learning. Well, maybe you will. Let's do the shameless self-promotion thing straight away. So if after this talk any of these things are interesting to you, talk to me. So I run, or help run, pretty much all of the R user groups in Australia. The Singapore one is so far safe from me. I like those guys, they're good guys. Anyone here from the R user group Singapore? They're good guys. Julian's a good guy. Data science, there's a data science Sydney group. I'm about to start a data science Melbourne group. Again, Singapore's safe, it's already in good hands. I do teach a course on fraud detection. In fact, most of my business these days is teaching courses on R, on data science, on fraud detection, just introductory data analysis, but increasingly on the issues that are covered in this presentation, which is about managing analytics, which is about the politics, the soft skills, the communication skills, the sales, the influence, the interface with other business units. The stuff that makes or breaks analytics, that's actually more important than whether you've got a convolutional deep neural network with 11 layers and dropout and max out units. And if you don't know what that means, well, it doesn't really matter. So the soft skills and managing data analysts, that's the stuff I'm really about these days. Also, there's a group called Analyst First, which is kind of like an international organization that I founded about 3.5 years ago to address not R, which I'm quite passionate about, and not data science in terms of its methods, which is, I think, what this group will be mostly about. Analyst First is mostly about the political, social, cultural management issues around analytics, which is where I think our industry is really going to be made and broken. And yes, there is a Singapore chapter, and do ask me about Analyst First. And as Kai-Shin said, if you're too embarrassed to do it publicly, you can always send it to that anonymous address. Well, Sydney and Melbourne are user groups. Anyone here from Australia? Oh well, do visit, it's a nice place. Have a coffee with me. I'm very big on mentoring. So I offer various services in analytics, data science, blah, 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 blah. And I'm willing to work for upside. So if you're a poor startup who doesn't have a lot of capital, I'm the kind of guy who'll say, okay, If we make a lot of money, we make it together. If we don't, I had fun. All right. Well, let's talk about the presentation, enough about me. So I'm going to present a few dichotomies that I think really need to be analysed before we can really understand what this data science thing is, how it differs from this thing called data engineering, which people don't want to talk about, but I think most people actually do when they think they're doing data science. And it's a necessary thing too, but it's different. I'm going to talk about how they're philosophically fundamentally two different activities. I'm going to talk about the need to engage management and the fact that that's not done terribly well. And by the way, that's not entirely the fault of the data scientists. I'll talk about this idea of exploration as opposed to building. Everybody knows how to build stuff. Few people understand that there is this perfectly legitimate and indeed very necessary activity called exploring. It's very different from engineering. I'm going to talk about extending that to the idea of an intelligence function for business, just like militaries have an intelligence function. And then, what does it take to become a really good data scientist? What does it take to be one? What does it take to grow one? And that's where I'm going to talk about notions of mastery and apprenticeship. So, I stick the word Zen in the presentation. Yes, that makes it a little bit different. It's actually, to my mind, there to be an accurate description. The reason the word Zen is there, the reason I keep looking there is because I can't see this on my screen. Oh, wait, it's right over there. What am I doing? God, I've got a teleprompter. This is great. Okay, the reason the Zen bit is there is that Zen, one way of looking at the word Zen, or I guess Chan in Chinese, I'm sure I've got the tone wrong. I'm tone deaf, guys, so I'll never learn Mandarin. Zen is the bare essence of something. It's also the part of a system, the part of a world, of a thing that is true, when everything else might be illusory or fleeting or not so important. So it's the thing that's left when you get rid of all the gunk. As a process, it's a way, how, I don't have to tell you what that word means, to enlightenment, which the Japanese call satori. So Zen is a process by which you get enlightened. So hopefully this 45 minutes will clarify a few things for you. And finally, Zen is this state that's kind of not too different from the real world as you normally experience it. It's a slight shift, but when you make that shift, the whole world looks kind of very different, even though slightly so. So I want to start by a very simple parable. Well, it's a parable, it's like a metaphor. It's like a little story about a parallel world. Just to give you an idea of the depth of what I see is the problem or a series of problems that it actually affects our industry and stops it from completely changing the world now. It will change the world, you know. I'm very passionate about data science, but I'm also passionate about solving these issues. So imagine you live in a world which is just like our world with two differences. The first difference is everybody thinks that that is what an airplane is. The second difference is in this world, your job is to build an airport. Now, the thing is, if you want to do your job properly, I would say that you need to take into account the design of airplanes. Now, there's only one problem. I think it's a problem. If your job is to design functional airports and everybody is convinced that that is what an airplane is, you've got an interesting challenge on your hands. Now, that's called a fundamental category error. That's like a fundamental, basic philosophical mistake, and when you're operating with that basic philosophical mistake in place, things are not going to work very well. Whatever you do with this misconception in place, whether you work around it, if you're realistic and accepting of cultural realities, do all those things that HR departments encourage you to do in this context, you're still going to end, I think, with a disaster. Managing expectations, being realistic, working around it, is actually not being realistic at all. It's kind of being wasteful and insane. However, what you do find that in a world like this, most people still want to focus on, the aerodynamics of the airplane. Are its gears pointing up or back? That's a very important question. What sort of tail is it? There are all sorts of highly priced vendors that are breeding the best of breed airplanes. There's a Boeing donkey, there's an Euro Aero donkey. All the magazines, all the journals, all the blogs, all the conferences are all talking about, what kind of saddles we should have for these airplanes, what kind of horseshoes, donkey shoes they should have. And anybody who's talking about this stuff is rewarded. They're seen as business focused. They're seen as very professional, they're seen as up-to-date and high-tech, whereas anybody who says, look, we've got a category problem here, this is a donkey, this is not an airplane, it's going to fly. Well, they're called negative, they're called a bit too academic and abstract, or perhaps they're told, look, quietly, you're right, but this is too challenging. We're not ready for this. We have to work in this context. I would say that in spite of it being too challenging and in spite of it being sort of rocking the cultural boat, etc., you need to get this fundamental issue sorted out, even if it steps on toes, even if it destroys whole careers, even if there are people who built their whole careers on the fact that, you know, donkeys are apparently airplanes. And in a world where airplanes are the sort of airplanes we think about, those people have no jobs and have to go do something else. Well, too bad. It's the only way to get viable airplanes and viable, you know, people flying A to B. So toes get stepped on, careers get affected, and it can be a huge cultural problem. But if you work within the paradigm, not much has changed because it's a donkey. Sometimes there are situations where fundamental truths have to be embraced. Now, why do I present this parable? Because I think there are a number of category errors of a similar magnitude in the field of data analytics, or what is, and particularly that aspect of data analytics we're beginning to call data science. There are a number of such problems. I will address a few of them in this presentation. Let's change tack again. We're going to come back to these. If it's not clear to you when we've hit some of these category errors, you can ask me in question time. But let's talk about what the heck is a data scientist. Okay. What I heard from my recruiter friends in Australia is that if a statistician wants to double their income, they change their they change their resume from statistician to data scientist. Seriously. Okay. What I also see are a lot of job ads, and by the way, I've presented this talk most notably to the Australian Business Intelligence Meetup group in Sydney, and the room had a number of recruiters in it. And what was interesting was the positive response from recruiters who say that their own clients very often don't know what they want. They're willing to spend money, they don't know what they're spending their money on. And it's usually data scientist must know Hadoop. I'll return to why a very curious sort of initial or major definition of a data scientist. So it seems that in many quarters at least, the first understanding is data scientist is a Hadoop guy. So it seems that in the job ads. Well, we all agree that there are tools out there other than Hadoop. Right? There's Python, there's R, they do other things, of course. Scala's become pretty important. So is a data scientist just a guy who does stuff with data? Okay, well that seems pretty general. I would say that every single IT person does something with data. Is this a redefinition of IT person? That's not very helpful. Okay, is it someone who does stuff with lots of data? So we're all loving big data. As I'll discuss later, I think a lot of this big data is also it's like the web 10 years ago. Data science, to my mind, is like the web 10 years ago. To say that it's all hype is absolutely false. It absolutely is changing the world. But to say that any of the or most or just about all of the major experts in the field have got it completely wrong and don't know what they're talking about, I'd go so far as to say that as well. So there's a lot of hype about what it should be because people are all, I think the futurists are not getting it right. But I'm pretty sure it will change the world. So is it someone who does stuff with lots of data? Is it someone who does stuff with big data? Well, to my mind, there are many, many things you can do with big data. And indeed, these days, most transactional data work is big data work. Is that really science? The one definition that I think sticks in most people's minds is, yes, doing stuff with big data, has the right hairstyle, works in a groovy sort of web analytics company, goes to all these conferences. It's sort of it's a brand. Data scientist is a trendy brand. Again, is that helpful? Well, it's common and it's probably a bit more specific than Hadoop guy, but perhaps we can do better. So now I'm going to try to do better and in the process shoot a donkey that really needs shooting. And what I'm going to do is I'm going to make a very key distinction. And the distinction is between what I call science and what I call engineering. I used to actually call it the distinction between building and finding. See, I think these are two fundamentally and philosophically different activities. Now, I'm not saying that everybody in this room is either a scientist or an engineer, although I believe that just about everyone in the room either does or aspires to do some combination of both. I would also guess that by this definition, most of you spend most of your time, if not all of your time, as engineers. I want to show you what the difference is, and I want to show you that the difference is much deeper than you realize. I also want to show you that management not being able to recognize this difference is a major failing. As a result of the presentation I mentioned to you in Sydney, recruiters came up to me and said that they're going to change their job ads tomorrow from data scientist to data engineer. That was one outcome. I was very surprised. This presentation isn't usually too friendly to recruiters, but well, they quite legitimately threw some stuff back at me, and I'll tell you what it was in the recruitment part of the presentation. They're interesting people, and they have an interesting job, and their point was, look, we're only working with the briefs that our employers give us. We know there's a problem. Well, good on them. So, is there a difference between science and engineering? What is the difference? Does it matter, and why? And why isn't my button working? So, first of all, I'll say that science and engineering, from the perspective of management, from the perspective of people who aren't in technical fields, from the perspective of people who failed algebra in 9th grade and haven't done any mathematics since, but have developed their social and political skills and are therefore your bosses, from those people's perspective, they cannot see a difference at all. You know, what's the difference in science and engineering? I don't know, it's all this technical IT stuff, right? What I want to make clear is that they're not just different, they're not even slightly distinct, they are direct opposites. Now, that doesn't mean they're in conflict, that doesn't mean you have to choose one or the other, they're in fact complementary opposites, which means they're friends, not antagonistic opposites, which means they're friends. Now, what does it mean that they're opposites? This opposition... Are you sure it's the right room?
Yeah, I am. I just didn't want to disturb you, but I already have. So I'm just going to go ahead and take your seat.
Are you calling me disturbed? Right, I'm watching you.
It's never
okay, so science and engineering are in fact direct opposites. Now what does that mean? That means that the skills involved are very different. The work style, the activity, the practice are very different. Now this is where it gets interesting, the personality types, good scientists, are very, very different to the personality types that make good engineers. The stuff, apart from high IQ, I think high IQ helps in both, but the sort of stuff that makes you a great scientist can make you a lousy engineer and vice versa. And it's very rare people, I find, that are really, really good at both. Those people are valuable. Managing science is very, very different to managing engineering. And the place in the business, the role that science has in the business is very different to the role it has in engineering. Now, guess which one business actually understands more, or guess which one business intuitively lumps science, analysis, etc. into. I'll talk about that. So there's an asymmetry, and the asymmetry is very much in favor of engineering. It's easier to understand, it's easier to manage, it's also easier to do, and it's the one people tend to gravitate to. I think this confusion needs sorting out, and I'll explain a bit more as to why that's the case. But this is the first donkey we're going to slay. Now this chart, if you're going to go away and say, oh yeah, there was this Eugene guy with that horrible Australian accent, I don't remember a thing he said. If there's only one thing I want you to take away, which I didn't put together, I stole it from someone's blog, but it's brilliant. So Shane Parrish from the farmstreetblog.com put up this diagram, which shows one of 3 reasons why engineering and science, particularly with regard to, are direct opposites. This is general. This is not just with regard to data science. This is any science and any engineering. Or more broadly, when I say science, I mean finding stuff out about the world or a system. And when I say engineering, I mean making something happen, building something. It doesn't have to be a code. It doesn't have to be a bridge. It could be a business. It could be a group. You know, Kai-Shin building this group is actually an act of engineering. Although Kai-Shin trying to see how this group operates, that's what he's being a scientist. So what you'll see is that there are these 2 arrows. There's this thing called scientific inquiry, which starts with the world, some system, some physical, and that physical should be in inverted commas, because it's really not so much physical as real or pre-existing. Something you didn't have an effect on, something you're just observing. Well, you collect some data about it, and then you, hopefully from the data, infer some insights, an abstract model, a theory, a set of ideas. So there's this flow of information from the world to a set of ideas. You accept the world as it is. You don't know what you're going to find when you collect your data, And what's more, you don't know what you're going to realize with that data until you've realized it. Science is not very planned. Science is not about planning, science is about finding things out. Science is not about making things happen, science is about creating models, ideas, distilling insights from reality. Guess what engineering is? Well, engineering starts with what we know about the world, and it starts with some idea we have about something we want to create. It's about building something. So we start with our abstract model, our design concept, and there should be a little arrow from the abstract model, the theory there, to the abstract model there. So we have, like, we know that gravity pulls things this way. We know that polar bears have 4 legs. And we know that catapults are great ways for launching polar bears. So if we're building a polar bear launching catapult, we can use all that theory to engineer a polar bear launching catapult. I'm not advocating cruelty against polar bears or any other bears, at least not in this lecture. Do what you want at home. So we, from an abstract model and a bunch of physical rules that we've inferred, some scientists have inferred from the world, we create a design and we build a new system. We do a new thing to the world. Okay, so information flows from reality to an idea with science, and from idea to reality in engineering. That's one difference. There are 2 other key differences. So take a mental snapshot of that. Hell, take a real one. Often in Australia, people will be pulling out their mobile phones and actually snapping that, tweeting it. So some of you may say, well, that was great, Eugene, but you've told me nothing about how to start a career as a data scientist. That was a great flowchart, but too many big words. It's all very realistic. And by your framework, most of us are actually engineers because we build things. We spend much more time building things than we do actually investigating and finding things out. You may also say, well, that's great, but it sounds a bit technical, abstract, academic, not very business focused. Well, my answer is, yep, I am saying that most people who call themselves data scientists are actually engineers. Nothing wrong with being an engineer, by the way. We need engineers. And most data scientists must spend at least some time being engineers as well. But they're different activities. Now, if you think that's too technical, academic, and not too technical, or maybe it is technical, but I think you guys can handle it. This is my preemptive slide for when I have a business audience. But with you guys, I think you're fine with the technical side. Too academic, again, I think you're fine with it. If you think it's too academic, too bad. Not relevant to business, that's right, completely wrong. This is extremely relevant to business because businesses don't realize that data science is there to help them think about the world, maneuver in uncertainty, deal with the changing world, and help them think. They don't understand that data science is a thing where the product is. But if the product is an idea, you're meant to do something with the idea. They're used to IT just doing whatever it does and not having anything to do with that IT, right? When the point is that you've got a system whose job it is to inform management, you need management that actually wants to be informed, that likes to think, that actually wants to make decisions based on more information. It kind of changes things. If they throw it all into the IT department and hope it's all just a sausage factory that delivers ill-defined value, you've got a problem. So that's donkey number 1. The other thing, I'm going to delve a bit more into what engineering is before I distinguish it from science, and I'm going to show you the next distinction. The next distinction is actually even bigger because it relates to data more directly. So engineers start with an identified idea and end with a design. I've told you that already. What do engineers do all day? They build or maintain something to predefine parameters, right? The thing about an engineer is if you're going to build a polar bear catapult, you're not going to spend a lot of time finding things out about polar bears. Hopefully that's already been done. Or there might be an investigative phase, but by the end of the day you want your polar bear catapult to operate within well-defined parameters. Uncertainty is the enemy with engineering. Engineering is all about building something and making it work to well-defined parameters. Code, if your code works in unexpected ways, that's probably not very good code, right? You need to know when something's a bug and when something's a feature. Uncertainty is the enemy, and when you're engineering, you want to build things on time, on budget, with the appropriate use of other resources and to appropriate parameters. Our catapult needs to be able to launch a 2-ton polar bear, 3 kilometers, at a height of such and such. That's engineering. That's how engineering works. And when you write code, well, you have testing, you have various other, you have various parameters in which, whether it's a bridge or polar bear catapult or a bit of code, it operates on it. We manage engineering with plans, timeframes, and specifications. Now, I can hear someone say agile. I'm going to talk a lot later about agile, about lean startup, also about methodologies like Never and Analyst First, which, by the way, challenge this whole waterfall planning framework. And by the way, a lot of agile fails and becomes virtual waterfall precisely because people don't understand this distinction. But generally, even with agile usually gives you a way of saying, we're still going to build a bridge and we're still going to build it to the predefined parameters. We're just going to be a bit looser about the process of building the bridge. So the final specification tends to be set in stone with agile. The process tends to be more flexible. Science isn't like that. In science, you don't know what the outcome's going to be. Engineers deliver products to predetermined KPIs. The unexpected is usually an unwelcome exception. So if you've got your KPIs for your polar bear catapult, but it's sort of suddenly discovered that your polar bear catapult somehow cures cancer, that's fantastic. But usually for something to cure cancer, you have to plan. Most of the time when it has anything to do with cancer and it's unexpected, it's because it causes cancer. So just about everything unexpected is usually bad with engineering. You usually work to milestones. Usually even with agile, you end up working with milestones, you usually have a specification. And whoever manages you, it's usually operational and technical management. In a large organization, there's usually a technical middle management layer whose job it is to manage engineers. They have virtually nothing to do with senior management, unless it really is a technology company where technology is strategic. So there are exceptions, but most of the time in a bank, in a telco, engineering has a whole dedicated management layer. Who knows how to do this? For engineers, the outcomes of what they do are things. You know, look at me, I've written this code. Look at me, I've got this system that does this. They make products. These products could be reports. So BI reports are engineering products. You know, I spent ages building this report. Well, I usually, when I talk to BI people, I find they don't talk to me so much about what they see in the report as, we've built this report to these specifications. Okay, thank you, that's engineering. They build business processes, sometimes they build whole businesses. And an engineer may do more or less the same thing many times, with slight variation. You know, we're going to make a polar bear catapult, now we're going to build a buffalo catapult, which has slightly different parameters, but you know, it's just the process of actually building. Engineers perform projects, they manage processes, and they're usually managed according to tight requirements. We know who the engineers are. We know how to find them. We know what degrees we need or what qualifications we need to identify an engineer. We know how to manage them. We've been developing methods to manage engineers for about 200 years, and now we're sort of challenging the stuff we developed in the 70s with all this agile stuff. Lean startup is great, etc., etc. At least that layer of management that deals with engineers knows how to understand them, finds them less stressful to deal with than to deal with me, finds them easier to train. It takes about, what, 4 years to get someone commercially productive as an engineer. There's plenty of them out there, and recruiters know how to look for engineers. In fact, there's a whole recruitment industry where we just have a bunch of boxes, you know, C++, Java, tick, Agile, tick. It's all pretty simple. Now, engineers have a very interesting relationship with data. Okay, so I said there were 3 important things. The first one was that diagram. So let's recap. That's an important one. Do take mental note of this diagram. The second one, which is this uncertainty is the enemy. Engineers work according to certain time frames. Engineers deal with uncertainty by saying, I don't like uncertainty. The more uncertain the system I've built is, the worse I've done my job. Unless my job is to build a random number generator. And even then its statistical parameters need to be certain. The third thing is this one. And this one is probably the most important one for us. Because when you're being an engineer, data is the resource that you move and manipulate. Your focus is on the system that transforms this data. This is where the 3 V's come in. Look at, who's not heard of the 3 V's, by the way? Okay, so the 3 V's are volume, velocity, and whatever. I really don't care about the 3 V's, because as a scientist, they don't matter. 3 V's are about, look at this amazing system that takes, it could take raw sewage, it could take oil, it could take water, it just happens to take data. Look at how much of it I can pump through, look at how quickly I can pump it through. Look at all the clever ways in which I can distill it, combine it, etc. The data is a commodity. The data is every bit, every byte is the same as every bit, every other byte. Every record is the same as every other record. What I care about is how quickly, how big, how many times. Data is a commodity. So when you're treating data as a commodity, you're being a data engineer. And this is very different to the way a data scientist treats data. let's talk about scientists now. So I've shown you the diagram which distinguished engineers and scientists, and I've told you that with regard to uncertainty and with regard to data, engineers have a very peculiar attitude to uncertainty and data. Scientists have the opposite view. They start with reality and they derive new insights. Uncertainty is the job. It's because we are uncertain about things that scientists have a job. And if you ask it, and the problem is that a lot of businesses want to know what's the ROI of what you're doing, Mr. Scientist. And you say, well, the ROI, I don't know what the ROI is. But if you don't keep an eye on all the things that I don't even know are out there, if someone isn't keeping an eye out on the uncertain things, your opposition is going to eat you alive. The military understands this. The military doesn't have an ROI for their intelligence function. The intelligence function is there to look for unknown unknowns. Well, that's what a science function is for as well. Because uncertainty exists, you have a job. What are you going to find? How valuable is it going to be? How deployable is it going to be? How is it going to be explained to management? I don't know. But isn't it better to find it than not find it? I would think so. Or someone, your opponent, your competitors might think so. While everybody thinks that this data science stuff is kind of nebulous, you're fine. The moment someone starts investigating and exploiting the unknown, you have a problem. This is how World War II went. I mean, you know, this atom bomb stuff, it all sounded very speculative, a whole lot of investigation had to do. But by the time someone got it right, I think it was pretty much game over. Yes, I know the atom bomb didn't really end the war as such, but there were a number of other discoveries along the way, by the way, like radar. The point is you invest in science, you invest in discovery, you invest in investigating things where you don't know what you're going to find. Because the alternative is to keep your head in the sand. I actually should put a slide in this, which is just an ostrich with the head in the sand, which is really what you do when you don't have a science function. As I'll explain later, there are some businesses that don't need a science function, and there are some businesses that do, and I'll explain what the difference is. Most businesses need engineering, even if they don't need science. So projects and processes are complete anathema. You get a conventional waterfall project manager who likes to tick boxes, and I've had these people manage me as a consultant. It's insane. Like, you know, what are you going to find? I don't know. It's qualitative. It's different. I haven't even looked at the data yet. I don't even know if your data's any good. You know, where's the box? You know, oh, we've ticked the box that you've received the data. Yes, but it was crap data. I want better data. Okay, finally you get the better data. Well, you know, have you found that thing you said you'd find? I said, well, I promised to look for it. I can't promise to find it. I don't know if it'll be yes or no. So being project managed, being process managed, being in a waterfall process with deterministic outcomes, or even an agile process with a well-defined outcome, is kind of nuts. Science and scientists, what do all day? They explore and interrogate data, or I should say explore and interrogate the real world for insights, which means no two jobs are the same. And no job can be specified too tightly. How long is it going to take? I don't know. I haven't looked at the data yet. What are you going to find? That's a really dumb question. You should be fired for asking it. You know, that's usually my reaction to this sort of thing. The findings are inherently uncertain. It's not just you, a scientist who's more comfortable with uncertainty. It's like uncertainty is the enemy when you're an engineer, and uncertainty is the reason you have a job when you're a scientist. Now, in reality, all of you, being data scientists, will be switching between, I am now writing my data transformation code, I'm now writing my algorithms, I'm now running my machine learning, and it's kind of like engineering. Then, when you see what the results are, you're being a scientist, because you have no idea what those results are going to be until you work. And the interesting thing is the management process, because what you've got is like a waterfall diagram, except you've got steps in your process where the outcomes are uncertain. So you don't know what, if you've got step A, which is engineering, leading to step B, which is insight, but step B has a whole lot of possible next steps regarding what those insights are going to be. You've got uncertainty in your process flow diagram. Now, this is Agile Squared. This is more like Lean Startup. Who here knows about Lean Startup? Okay, so Lean Startup is a kind of methodology, and by the way, the original Agile, true to the Agile Manifesto, is comfortable with this as well. This is how you operate in the real world. In the real world, we only learn about stuff when we do stuff, and we adjust accordingly. In a sort of fake bureaucratic world, we have everything planned ahead of time. So no two jobs are the same. Findings are inherently uncertain. Very strange kind of people, these scientists. They're focused on the data. Now, the other thing is when you're focused on the data, it's like what I see in big businesses, the focus is on tools. Enormous amounts of money are spent on software. Well, as the world is discovering, open source is A, more powerful